Hello, and yes, we're welcome back. It's a new year of CodeZone, and I'm absolutely full of a cold. So much so that I've entitled this stream Geometry and Snot. And yes, some light theme to wake you all up there. I like that. Annie's here. Oh, good, we've got quite a few people here. So, Annie Cater, hello. Jizz99, hello. Standard in, hello. Magetsa, Bixie. So far, that's it. Oh, Siggy's there as well. Yeah, hello, Siggy. Right, what are we talking about this week? Well, firstly, over Christmas, what's been going on? Not much coding in terms of the editor, but quite a lot of coding on the Geometry 2D library. And I'm just going to give it a bit of a plug because a lot of good stuff has happened, and we've now made the demonstration project available online. So I'm just going to take that link there. Best select it, haven't I? Take that link and drop that in the chat so you can have a play with it yourself. My intention is to add that to the repo. So for those that didn't see last time, the community sees quite a lot of people now. We've had 27 PRs, I think. Yep, 27 closed off. So there's none open. There's no outstanding issues really in this case. There's more discussion points. And there's a lot of functionality in it now too. Let's have a look. So we can move the shape. So everything implemented here is implemented by the geometry library. So there's all sorts of things going on. Let's have a look. So yes, I'm absolutely full of a cold. Sorry about that. We've got different shapes. We can see where they're overlapping and colliding. I've put a laser beam in because laser beams are cool, but it also is a nice way of testing the ray stuff. If you hold down the right mouse button, you can also cast rays from the edges of the screen and see how they interact with the various shapes. And a lot of this work has actually been done by the community. It's not just me working on it. I did a little bit of the ray stuff that's been going on, but a lot of the more complicated geometry things have been done by other people, which is good because I'm not that strong when it comes to sort of geometry layers. This is pretty cool. We can bounce the ray inside the circle. Now, why does it escape? That's because of the really crude way I'm doing ray shape detection. The ray has to hit a different shape before it hits itself again. It can't bounce against itself, basically. Let's have a look. First time chat from W7390. Greetings from El Salvador. Not somewhere I have ever been. Pliskit, hello. Good to see you too. Yes, CodeZone 2024. We will be continuing with the editor build. But because I haven't really done much code on the editor, I haven't got a lot of progress to show. But I did fix a bug. Because it was rather embarrassing in the last episode of CodeZone. I sort of said, let's have a look at the geometry, and it all just crashed and collapsed because it is a bit fragile. Anyway, I recommend you go and get the library, steal the code for yourself because there's all sorts of interesting bits in there. Now, is Alter Ego here? Alter, if you're here, shout out hello. Oh, there we go. Hello, excellent. Gruffler, good evening. Right, Alter, or Holy Seraphimon on Twitch here, as I've just received a big complicated DM, and I've been digesting it. I only really saw it before I started the stream. So just to let you know, you're not being ignored. It looks pretty cool. Alter has been working on one of the types that nobody else has been looking at. So let's have a look at the code here. So single header file, as you all know, for the library, just pull it in. And if we look at the function matrix, we've started to fill in a lot of the blanks. But we've got sort of nothing that represents polygon. But that is something that I've actually sort of hinted at that I want existing. Let's have a look at, I think we even put in a very basic prototype. It doesn't do anything. There is no representation of polygon in this library. Now, Alter's gone away and worked on various polygon interactions. And I don't know what the code implementations for those are yet. I've not looked at them. So there we've got the polygon type. Let me just zoom in a bit so you can see what's going on. Lost it. There we are. The polygon type. At the moment, it's just a vector of points. Now, there may be more information to go into a polygon, but that's what it is right now. My approach was to really just leverage the triangle routines to try and make the polygons work, but I guess without a robust triangulation routine, that's not really sensible yet. Now, I do actually have a fairly robust triangulation routine. I've not uploaded it to the library right now. So I guess, Alter, you're working on edges and lines and diagonals and all that good stuff. And what Alter's also submitted is sort of the basis of the basis of a collision detection system and framework. At the moment, that's kind of hinted at too. There is a little bit of implementation. If we go down to the bottom of the code file, we've got buried in here some more interesting routines. So we've got reflect, which is what you saw with the... I can't stand GitHub. Every time you click on something, the whole screen moves. We've got reflect, which is these routines which reflect rays off various shapes. So that's sort of the precursor of collision. But we've also got collision functions. And these are optionally return a collision point and a normal of a ray and a triangle. Now, we could potentially extend these collisions to different shapes, not just rays on shapes. There's still discussion to be had about that. Anyway, over Christmas, there was some commits, but the momentum behind the project did sort of slow down, understandably. It'd be nice if we could get this back up and running and finish it off. So, Alter, yes. Yeah, it was a big sort of data dump in my direct messages. And yeah, I'm working through it. But just to let you know, I've seen it. I've not ignored it. Danny Cron, good evening. Yeah. The Dr. Octo. Hello, Javid. Hope you're doing fine. I'm okay. I'm full of a cold. I have a stomach ulcer. And I've twisted my ankle. So I've been better. Oh, dear. But I thought, you know what? I put off the stream. January is a very busy month at OLC Studios. It's there's several family birthdays going on and family anniversaries and things like that. Just January, everything happens for us in January. So it's a bit chaotic. It's always been this way. So it's why we've not really seen... I was going to stream last week, but then I forgot that it was actually... it was my wedding anniversary, which was rather embarrassing for everybody concerned. And my room looks wonderfully clean. Yes, it does. I have gutted the room. It is ready to start doing some video making. That's exciting stuff, isn't it? At least I can see the camera again. It's right there. And I've got my screens ready. And I've also updated all of my software. I've had a complete sort of refurbishment of my my environment. I'm no longer using DaVinci Resolve 12. They're up to version 18 now. Can you believe that? Room's lost its soul. Yeah, it will accumulate soul as the evening progresses, I think. Depends what I had for tea. Right, let's see where we're at. There's the geometry library. Go and abuse it, use it, play with this. This gets quite addictive. How dense can you make the patch of red has been a game played by various people on the Discord server. Can you actually get it to colour in all of the pixels within a certain region? It is possible, but for small regions. It only bounces 100 times. There's an upper limit on the ray bounce. It does get quite addictive to just sort of play with. I like it, and there's plenty of games based on this sort of idea. But it did make me think it might be worth hacking something together for a jam, maybe. I don't know. Right, that is GitHub Geometry Library. Let's just see what have I got open? Have I got Geometry Library open? I have. Yeah, we'll have a quick glance at some of the crazy code. Okay, now because this is a community project, and because even though I pretend that I know what I'm doing when it comes to C++, there are actually some far better C++ programmers out there than me. I know, couldn't believe it. Now, a good contribution to this project has come from a fellow called Starfleet Clone on the Discord server, and because I wanted to sort of explore releasing this library as a very modern C++ thing, I've got to sort of embrace that. I can't pretend it's not happening. Sorry, Magetsu, I know you'd like us all to regress back to just C, but it is kind of happening. So one of the, I guess, paradoxes of this library has been this following problem. All of the shapes, the basic primitive shapes, let's go and find them. Where are they? Well, they're kind of scattered all over the place, but let's line, for example. You'll notice that none of them inherit from anything. They have no common base type. Now, is that a problem? Well, no. The reason this exists is to try and not be object oriented. It's not because I'm anti-object orientism at all. It's simply because I want them to be applicable to all sorts of scenarios. I don't want to have to force the user into a way of thinking about how to use these routines. If they just wanted to cut and paste the code and adapt it to themselves, they can do. But not having a common base class between all of these shapes does have some problems. How do you store them all in a container, for example? Fine, you can store a load of rects in a container, you can store a load of triangles in a container, but in the demonstration application, we want to have sort of a whole different bunch of things. And this is where all of this good stuff comes in. So you can all of this sort of modern C++ vomit you can attribute to Starfleet Clone and a handful of others on the server too who are chipping in. But it makes use of the visitor pattern, and it has all of this like really cool stuff in. I'm not going to talk about this right now. It is quite complicated, but ultimately it looks for lambda functions which are defined, prototyped in the way that we want them to be called within the library. It's quite nice. There's obviously some runtime overhead associated with the visit method there. And I just thought this was actually a very nice application of this approach. And potentially would form the basis of a video I'll make later this year. I need to explore this routine a little bit more and see what the power is. It is quite complicated to sort of describe and see what's going on. But it did manage to reduce the code here from one massive sort of big table of comparisons into just a few hundred lines now. The way I described it on the Discord is not entirely accurate, but a good way to think about it. It's kind of like a compile time polymorphism, although there are some runtime decisions based on that. So it worked quite nicely for basically storing all of these different shapes in a single container. Where's the origin of all of that? The bit that makes it all work is here, this line here. Using standard variant, which is, I understand, is a type-safe union. People will criticise me on that. Let's have a look. Add a scoring system. Make anything into a game. Get it on Steam. Yeah, standard. So it is new to me. It is a bit tough to digest. It is absolutely not entry-level C++ because it's doing a lot of things. And how to sort of use and abuse it is something I'm still learning about and how to make it work. So you see sort of weird things like this. What exactly is going on here? And I've tried to add some comments to refresh anybody reading the library. Anyway, you do need C++ 20, I think, to make any of this work properly. And Pyrotux and others have contributed significantly to the maths, but also making it work with Inscripton. So it should compile with the latest version of the Inscripton compiler too. So that's the first geometry of the title, geometry and snot. Type-safe union is accurate enough. Yeah, there we go. Okay, good. Oh dear. One of the other things that I've sort of latched on to in my way of thinking about programming now is the use of standard optional. As on the whole, we're being pushed away from just pointers in general, and sort of having objects declared all over the place, and there's fancy acronyms and things for these behaviours. One of the things is standard optional is quite nice. So in the past, we would have perhaps called a function and it would do something and create an object. And if it didn't create the object, if it failed, made me jump. Thank you, Londo. I need to turn that down just a little bit. Lift it deck. So yes, so we had a if you create an object and it fails, you might return null pointer. Now that's fine, but it's a pointer and the world is going towards I don't like pointers very much. So standard optional, that's what I'm looking for now. Where can we see a standard optional doing its thing? Let's have a look. Where have I got one? Check intersects. No, that's returning vector. Standard optional. Standard optional. I'll be able to find one now. Are they buried in here? I think they're buried in here somewhere. Okay, that's probably not the easiest line of code to digest, so let's go and actually look in the header itself. And we'll have a look at some of these ones. There we go, standard optional. So if we want to signal to the caller of the function that well, we haven't quite done what you wanted. Or in our case, the ray hasn't hit the circle. There's no information for that to return. So normally in a collision function, you'd want it to return some properties about how has that ray interacted with the circle. Well, if the ray doesn't interact with the circle, there's nothing to return. And I don't want to return sort of null or a special encapsulated object. I guess it's still doing that behind the scenes, but standard optional kind of makes it safer in a way that then I can go ahead and I have to test to see if the returned type actually exists before I can utilize it. So it does add some robustness to the code. The overhead, of course, though, is things start to get a bit long and wordy. So it's been interesting. It's been an interesting deep dive into some of the, I would argue, more esoteric parts of the C++ language. But then again, I'm an old hat at this sort of thing. So I'm learning as I go. Trying to up my game here, up my creds. Yes, it's always loud, isn't it? Crafts Dwarf 404, hello. American 2050, hello. Now expected. I don't know. That's again. These are sort of the later things I just simply don't had no need to look into. My professional code base won't go this far, and things like the Pixel Game Engine I've been deliberately trying to keep simple. So people can digest it and use it with older resources. If all you've got is a handful of older C++ textbooks lying around, or you like the older videos, it's important to keep things understandable. Because I do actually find this, if you look at that as a beginner program, there's a lot to digest there. There's a lot going on. And is that going to be a problem for C++'s longevity? I think so. Even though it is powerful, it is raising the barrier to entry, and I think perhaps worryingly. The nice thing about C++ though is you don't have to use these things; they're not compulsory, and that's why I think there's a difference. Anyway, yeah, that's a lot of template vomit. It is, and the whole header file is actually based on templates, and there's this actually this is quite interesting because there was a discussion on the Discord server because we've included some code basically because C++ reference website said to include it, and we really haven't quite worked out what it's doing, but it makes it work, so. So if you want to take part in that discussion, head over to the Discord server and enlighten us. If you kind of understand what's going on here, then good for you. Right, let's move forward with what we're going to talk about tonight. Yeah, I'm going to move on. I'm not going to carry on discussing that. I'm not qualified to discuss this. Speedy, hello. Only the wizards. Well, our Discord wizards don't really know what's going on here. Yeah, well, no. This bit we all kind of understood. Now, interestingly, on Visual Studio, the whole thing works without this, but on Inscription's implementation of GCC, it doesn't work. So there is something more evil going on behind the scenes here. Visual Studio doesn't seem to actually care whether this exists or not. So have a think about that. Right, well, so I know there'll be some compiler warfare going on at some point, but leave it at that. Right, I'm going to close this because I've talked enough about the geometry library and about to say, have a go with it. It's good fun. Steal the code. If you use it in something, let us know. See what's going on. Well, I will do some promo of this library later this year, I think. Right, I can get rid of you. Good. Right, other things I've done. As I mentioned, I did a bit of digital housekeeping. So I've updated all, got the latest versions of everything that I need to use. Everything's running quite well. I've had a good cleanup. And I finally moved away from OneNote. Not OneNote, sorry, OneDrive. Of course, I've not moved away from OneNote. We're going to be using that in a minute. But moved away from OneDrive to sort of backing all this up. It is now all properly gitted. I mean, it kind of was anyway, but I've moved away from it. Has it improved the compile times? No, not in the slightest. I think the compile times are just what they are, and it is quite strange, isn't it? It's really sort of bogged it down. That's most likely down to a couple of header files within the Pixel Game Engine 3 implementations. Maybe they're a bit tough to digest, and perhaps it's worth looking at some sort of pre-compiled solution for those. I'm not doing that tonight. I have too much brain fog going on with the cold tonight. So that's why I wanted to try and avoid getting stuck in the weeds with some of the details. But what I will show is we'll launch the editor. Why not? We've been waiting. I'm sorry for the coughing as usual. The coughing isn't actually the cold; it's the stomach ulcer, which is not great. Right? I don't recommend that you get one of these. Here we go. This is the editor that we know and love from last year, but I've added one more feature to it, and it's the ability to add geometry layers. So a geometry layer looks and feels a bit like a tiled layer in how you interact with it, but I've got just one function for the time being. The idea is you can pull up a Lua script, and you can place an object. Oh, let's do it again. Pull up a Lua script, and the Lua script will then create geometry for you, depending on what you specify. Now, at the moment, this is just a little hack together prototype just to see does Lua handle this sort of thing very well. So I can go down to rectangle and I can draw a rectangle. That's not very exciting in its own right. It's a circle and a rectangle. Let's have a look at something a bit different. I go to circle here and I specify far fewer edges. Let's have a look on here, and then I use the draw command. You can see it becomes a polygon. Now it's the Lua script that's doing that in the background. It's generating vertices for me to then go and play with somewhere else. I can't at the moment move these around, I can't edit them, I can't select, I can't do anything. I just don't have that functionality. I just wanted to test, can we get Lua to spit out geometry in an interesting way? And we can. And once I realised this, it made me think, what the hell am I doing with all of this geometry stuff? What's it for? How do I need to describe it? What's it going to be linked together with? I really had no idea. I'm just sort of flapping about. It's the fun shapes, and what do I want to do with them? As some of you know, I built a prototype of this editor last year, and I kind of want it to go down that road. We need to think very carefully now about laying the foundations for how we get all of this geometry stuff linked together. A dev drive partition from Tiny Big Games. I have not heard of a dev drive partition. One of the things I do is I actually make sure all of the Visual Studio junk is mapped onto an SSD drive. So all of those sort of intermediate object libraries it creates, all the IntelliSense junk, gigabytes and gigabytes of stuff, that's actually running on a very high-speed drive I've got in the machine. I've sort of hard burned that into Visual Studio. That's where it should always put the junk for the projects. Yeah, sure, you can post a link about it. Wait, that's not a circle. Correct. And if we go even smaller, now, so actually absolutely nothing works, right? So I can change that. Oh, hang on, that did work. How the hell did that happen? There we go. So we go down to a few edges. There we go. So it's not a circle. Don't need very many edges for a circle. And of course, a rectangle is just a rectangle. We'll go and have a quick glance at some of the scripts for that. And for those that haven't seen before, it all works in sort of multiple axes as usual. You could copy your project to a RAM disk and build from there. I don't think it's access times. I think it's just the compiler is slow. It's clearly got something where it's got to chew through a problem before it gets to what it wants to get to. It shouldn't be too slow if we start making minor changes tonight. I wanted to show some of these scripts. Let's see if I even got them loaded into the project file. I probably don't. I've got tiles ready. Let's have a look. Let's add a new filter into tools. Yes, add filter, new filter. I hate filters. Why can't they just be folders? Geometry. Oh, that's not how you spell geometry, is it? Fail, spell fail. Geometry. And I'm going to add to this some existing items. Scripts, tools, well, vectors I call it. We'll rename that in a minute. Shapes. Let's just add all three. so we can have a look at them. So this is the circle one. Now it's in Lua, and it should look very familiar. In fact, the scripts themselves and the thing that executes the scripts is no different from the tile one. Why should it be? It just has a few different functions inside that we'd need to populate. Now, the script, all it's got to do fundamentally is whenever this function is called, construct geometry, is spit out a bunch of vertices. And the vertices, excuse me. And at the moment, it's too dumb because it spits out a bunch of vertices and it assumes all of the vertices are stored in a fan configuration, which is no good. So this is say it was just a hack to see does the linkage actually work. In this case, the construct geometry function will take in the slider value, goes away and does some maths, calculates the position on the outside, fills a vector full of coordinates, and just that's it. That's what we see. So linking it together is a work in progress, and well, it kind of works. It does what I need it to do. Doing the dragging and dropping to place the shapes was a little bit more challenging. The script itself basically maintains a very simplistic state machine to know whether you're which node you're positioning and what that node means in the construction of the shape. When you're drawing a circle, for example, you don't want to draw all of the individual vertices. I just want to place the middle and then place a point on the circumference, and it goes away and creates the circle accordingly. For the rectangle, you place the top left and move over to the bottom right. So it made sense to me that sort of discrimination behavior is maintained by the script. It's not actually the user environment, because certain shapes and formations might require 3 or 4 construction nodes. If we wanted arbitrary meshes to be drawn, then effectively you are placing the vertices by hand. So that's why I'm given that behavior to the script. Let's have a look. What are we up to? C++ is just slow to compile generally. Yeah, I'm just used to it being quick. I think that's the problem. Hello, is this a sacred geometry stream? Yes, and snot stream as well. Does VS have a folder view? It probably does, but it's not quite the same. It doesn't. Even though I dislike filters, I just like the look and feel. My brain's too wired into that. You love IntelliJ. VS is folding function lines. What, this bit? This is the one thing I probably never use. I just never use them. I think the thing I like the most on Visual Studio, and for some reason, because we're in a Lua file, it's disappeared. I do like the code maps. That was a really nice addition. That was actually added years and years and years ago, and Microsoft hid it behind an option. So if people think, oh, look, they've stolen that from VS Code. Yeah, oh yeah. No, they haven't. It was the other way around. Right, so what I wanted to do tonight, before I completely lose my voice and will to live, to be honest, is I wanted to sort of describe and capture how I want to represent geometry and why do I want to do it that way and how we're going to link it into the editor. And because at the moment I'm just sort of coding in the dark. And so I'm going to dazzle you all now with some OneNote. Ba-boom! Yes, OneNote. Have you tried the Control and T dialogue to find stuff from... Oh, that's... yeah, didn't we discuss that at one point? Control and T. No, I don't like search stuff. Oh, no, the one I like is it Control and Tab? Yeah, that one. I quite like that one. Visual Studio, by the way, is going through like a rapid change in sort of how it's being developed. I don't know that officially, but you can tell by the way that they're now interacting with the dev community on it. There's a lot of Twitter posts and blog posts and things going out by the dev team, and it's nice to see that they're actually quite reactive to sort of the user base of it. And so you've got long-term users like myself who grumble and moan about things that haven't changed in years, but they're actually really adding features in. The GitHub integration I find now is actually really, really nice. The only downside is what I can't do, the only Git thing I can't do, I can't review PRs through the Visual Studio environment, but I can do pretty much everything else. You can just start typing symbol names. Remind you of the Windows shell. Hello everyone, great to catch you on the stream. Hello Davey40k. They keep touting the idea of yet another UI. Well, as long as it doesn't go back to having all caps for all of the menus. that was the Visual Studio 70s phase. You just don't want to talk about it. Right, yes. Avert your eyes. There we go. It's nice this because it sort of basks me in a pale glow and I'm illuminated on screen. Shows me at my most nerdy. And I've got a new, you won't be able to see this, I've put a new nib in my One Lone Coder pen. Maybe I should auction the old one off. I don't know. So what am I doing with geometry? Why am I interested in geometry at all? Right, and there's various set of things that I want to describe here. So the first thing is I want to be able to sort of signify regions within a tile map. So I'm just going to capture this sort of stuff. Regions within a tile map. So what are the regions? Well, you might, for example, created your tile map in the background. You want to be able to specify perhaps a different music plays in this region, or the ambient lighting changes as you move into this region, or they work as camera locks, and that's quite an exciting one for me. So if you take a game like Metroid on the NES, Super Metroid on the SNES, it has quite an interesting way it interacts with the camera. Particularly on Super Metroid, is you have sort of zones, regions where the screen moves fluidly, but the camera is clamped within the shape of a boundary, and you go through the doors and move into the next region. Well, of course, the map doesn't need to be segmented into regions connected with doors. The map can just be the map, and you can limit the camera's movement to within certain geometric reasons. So, sort of overlaying with tile maps. Potentially collision stuff as well. So if you wanted to have slopes or blocks or maps that define edges that you can interact with, rather than having collision tiles and working at that level, you could potentially just put geometry over the whole tile map. So I think they're the obvious ones because that's stuff we've all done before. There's nothing new there. But if you were to put in a reasonably robust geometry engine into your 2D editor, I think you may also want to leverage it to do other things, and these are the more exciting things. So I would like to use geometry to create assets. I think on the whole the world is moving away from sort of pixel-based assets really, and moving towards what more sort of vector-based assets. And Pixel Game Engine 3 is going to sort of be geared towards vector-based stuff. And I felt that, well, if I'm releasing a tool which is fundamentally vector-based, then I need some editing tools in order to allow people to create resources. Why haven't you just used SVG format, Javid? I don't like it, and it doesn't actually support animation very well, and there doesn't seem to be an established standard really for SVG, and it's just another XML rubbish thing, isn't it? I also don't like the tools. I don't like Inkscape. Everything about it. No, don't like it. If somebody wanted to create some sort of importer, fine. I'm not interested. I'm also, I like doing these things for myself too. I'll await all of the hate mail about Inkscape have been coming my way, I think. I'm going to create something called. I don't really have a fantastic name for them yet, but in my head I've started calling them vectorials, which are the sort of geometric equivalent of sprites. So I suppose a sprite is a collection of pixels, vectorials is a collection of geometry which defines a shape. If you wanted, for example, a person, you could have a circular head, a triangle body, a couple of legs, for example. Right? It's defining it at that level. You get a lot of benefits from doing things this way. It's reasonably easy to do things with the GPU to distort them. They're considerably easier to animate than sprites. They're scale independent and invariant, and they look pretty cool. I just quite like them. So I wanted an editor for this. I want the editor to be somewhat artistic to use. So I do actually quite like using a stylus to do sort of my artwork and my assets. SVG, yes, we've just mentioned that. We're not doing SVG. Excuse me. Vectites. Well, I guess there's also vectrites, isn't there? Don't know. But they're basically going to be a shape, but they can also be accompanied by temporal transformations in order to animate them. And I have actually prototyped these things too. What I was saying, I want sort of the geometry stuff to be reasonably intuitive to work with, and that's, I feel, quite important, because if you're going to start trying to be creative with these tools, if you've ever used sort of animation tools, you see, what's the popular one? It's free, actually. Oh, look at this. Advanced Critics. Yeah, bye-bye. Thank you, Magetsu. That doesn't happen very often, does it? We don't often get spam bots in here. So we will sort of move beyond the sort of abstract here. I do actually want to start getting into some of the detail of how we're going to store geometry and why it's quite useful. But I want sort of, these are, I guess, development aims of what we're doing here. I want them to be intuitive to create. Intuitive, yes, to create. Now, that's not just a case of having lots of icons and tools. That's actually really thinking about the linkaging between shapes and how you can construct multiple shapes. And this is what I was thinking of doing so far. So we know we're going to have a geometric layer. And my intention, let's just draw a geometric layer. I guess a geometric layer is a non-bounded infinite space, right? It's in all axes, I guess, with some sort of origin, presumably in the middle, then, to define our 0, 0 position. Unlike a tile map, I guess you don't really need to sort of define the array or anything like that. It's the shapes are going to be sort of independent; they just exist. But this is a bit of a lie, I suppose, because even though in theory it's going to be sort of infinite in all axes, what I would like to do is use my quad tree implementation to store where the shapes lie, because I think if you've got, let's say you've got a level, so you might have a rectangle up here and a bit of a triangle down here. You might have more stuff like here for platforms. Perhaps these are all of your polygons that are used in collisions. At any one time, you may need to do some sort of rapid search to work out what's visible. You don't want to, or within some sort of testing range. So I'm going to use the, I made a video about this, the quad tree class that was developed in that video, as the fundamental storage container for all of these different geometric shapes. Now, unlike the geometry library that I started this stream off with, these will all have some sort of common base class, so that becomes a bit more trivial to do. The second thing that I would like these shapes to have is several different modes of interacting with them. I think I've not tried the newer blenders, but certainly the older blenders kind of encapsulated what I would like to do, just in 2D though, not in 3D. In that you can work with things at the object level. So this is what we've just seen with the Lua scripts. You might get, in object level, you can work with something with a couple of construction nodes. In this case, the rectangle, you can drag and drop it, and you can move them around and potentially rotate them. That's something at the object level. I'm going to draw a circle in here just to sort of also prove a point. So at the object level, we would have sort of these two nodes here, and we can construct a circle just using that information. But the output level, or the vertex level, is actually the more interesting one. So for circle, we might generate lots of vertices. And some sort of description of how that geometry is constructed. So in this case, it could be a fan of triangles. I guess ultimately, it all has to be triangles. And most of the graphics APIs have various ways of implementing constructions like this. So in Pixel Game Engine, we've got triangle fans, strips, and independent triangles on their own. Magetsu came up with something interesting recently. They discovered that the latest version of DirectX doesn't actually support fans. Was that right, Magetsu? Was it DirectX that didn't have fans? Which I thought was unusual, but there you go. Why is this important to have edit in this mode? And that's because I want to be able to edit the individual vertices. Now, that brings an interesting problem. Yeah, DirectX, yeah, so I thought so. People say these things and think I just don't pay them any attention, but actually it does sink in. One of the reasons you want to be able to work with the vertices independently is perhaps you want to shade them different colours, for example. Let's see, we have a red one here, we have a blue one here, and it would get shaded in as necessary. Perhaps you want to reposition them, so maybe, let's put that one there, maybe I've got a vertex that I want to drag out here, and it changes the shape. So we can actually have any shape, but you are bound within these very simple rendering constructs. So if we maintain these constructions to only be describable in ways that the rendering system understands, you'll actually get a lot of throughput. You don't need to triangulate in real time. The artist, the content creator, can actually work with things in a level ready to be used by anybody's game engine, and that's the critical bit. Remember, this 2D editor is not specific for my stuff. It will output stuff in formats which are easy to integrate into other people's code without needing to rely on my libraries and my ways of doing things. Now, the paradox you got here is, once you've deformed a shape like this, the original circle construction shape is no longer valid, but you might still want to keep hold of it. This gets a bit tricky, and the operator just has to be careful, I think. If you change the size of the circle, it's going to regenerate those vertices, and of course put them all back on a circle, and you would lose this anomaly. You could if you didn't change the number of vertices, you could maintain the colours and that good stuff, but you would lose the geometry. So we need to play with that idea to see how it works. So we know that the whole thing is going to be stored within a quad tree. And we've got some intuition about how the geometry shapes should be constructed. The next thing I'd like to include is relationships between the geometry shapes, and this is where things can get quite tricky. And effectively, this allows us to have a hierarchy of geometry. Why is a hierarchy of geometry useful? Well, I'm going to implement this through the concept of a layer being able to have child layers. So it's not shapes with child shapes. Again, a layer is just a construct to make things easy to understand and work with. It really doesn't mean anything in terms of the end result, I suppose. I'm babbling a bit there. But the idea is you can have a layer transformed relative to a parent layer. Why is this useful? Well, let's say you've constructed your character and you've got a bit of an arm. You could have another arm, which is this one and this one share an origin. Well, or they share a relationship. And of course, you can then specify sort of the rotation and scale parameters of that particular layer of geometry. So there could be all sorts of things in that layer that also get scaled and manipulated by the parent. And the reason I'm bringing this up now, you might think, how can we possibly be thinking in terms of animation, is I think it's so fundamental to make sure that these hierarchies are robust now, before we get really stuck into developing the bells and whistles of the tools. And so that's what the next few weeks are really going to be focusing on for the development of the editor. So we'll look at having a common interface for all of these tools. We'll be able to edit the objects independently. All of the objects that share in a particular layer, there might be brushes, for example, where you say you want to just colour in all sorts of different vertices rather than selecting it and working on them. So you could have like spray paint brushes, which you could use across the whole layer. And of course, it's intelligent enough to work out which vertices you actually mean. I think once we start working with this, we'll start to see some of the tools come alive, and hopefully it'll start coding itself. There is one final sort of consideration when we're working with geometry, and that's the idea of strokes. It's very common to have a polygon of some shape, and basically everything we've talked about so far is going to look and feel a bit like this. However, it's often cosmetically, aesthetically, is that the right word, desirable to be able to stroke the shape by giving it an outline of some description. I haven't thought about this yet. Obviously, the stroke is going to have to be a unique polygon construction in its own right, and potentially with some interesting algorithms to actually construct along the edges and add radiuses or sharp edges, that sort of thing. It's very common to have a stroke. Well, I guess it depends. So, stroke is on the radar to think about, but it's not sort of. I don't think it's necessarily a feature we need to worry about from day one. So, my potential roadmap for this is to start thinking about the layer quad tree. The layer quad tree to begin with. Then I want to be able to sort of have multiple objects in that quad tree. I want to be able to select the objects and go into sort of a vertex editing mode. Vertex edit and object edit, which is, yeah, it's stolen a bit from Blender. And for this sort of relationship, we need sort of a parent-child, or just a simple parent hierarchy. Oh, I before E, except after C. Hierarchy. There we are. Yeah, curves and things. Possibly is the answer. At the moment, the curve would only really exist like this, for example, if we have a good line drawing front end on this somehow. So once we've done the strokes, potentially we can start to think about how curves can work. If we're talking about more sort of curved shapes, arbitrary curved shapes like this, and how does that get represented reasonably efficiently with triangulation, then that might be the topic of something else that we need to think about. How do we efficiently go about breaking these parts up? I did mention before that I've got a video in the works for that. I think I might have shown it on the channel before. Have I actually demonstrated this? Oh, do I actually have project? Let's have a look. Oh, I wonder if it works with the new geometry library as well. That's interesting. I don't like this what's new screen. It annoys me. Triangulation. Here we go. So there's a story behind this potential video that's coming up. Let me just start this. As a bit of fun one evening, I thought, how the hell do you triangulate a shape? And it's not something I've ever needed to do in my career or life, until I started thinking about building a geometry editor. And I thought, you know what, instead of sort of attacking the research papers and Googling it, if I wanted to do it from first principles, how would I do it? This kind of evolved. For those of you that have seen my polygon collision video, where I came up with this approach where the diagonals of the convex polygons interacting with certain edges can actually be just as good at giving you the collision information. And it was surprising in the comments how many people said that they've just never seen that before, and were surprised at how effective it worked. I've said in the video at the time, I'm sure it must exist. It's not novel, but I don't know what it's called or how to attribute it. And so I'm hoping along a similar line that my triangulation routine is actually the same. And it turns out the actual triangulation routine isn't very big. So there we go. So once we've got a set of boundary vertices, that's it. And we can see if this works. I don't know if it will. We may have to change a couple of things. We've not got any red lights. We'll see if this works. Dr. Octo, thanks for the great content. Oh, thank you. Yes, thank you. I'm not too well today. I should be better soon. Could some of the geometry stuff be pooled nicely? I don't think every decal should have their own vector. Yeah, possibly. I think that's more of an implementation of the end result of the editor rather than the editor itself. Anyway, that compiles. That's good. Let's try running this. Oh, what have I got buttons I need to press? If I click Control, right, so I'm placing some points. It drew a triangle. So that's defining some sort of convex boundary. Want to get it to triangulate? Ah, okay, yes. I can choose sort of inner or outer. Right. Okay, I'm remembering how to use my own tools here. So there is a polygon that we drew just by drawing the boundary, but you want it to sort of intelligently handle the triangulation. So there we go. See? Isn't that nice? Now this is a different structure. So it started off as a fan, but instead now it's formed something else. And I don't think I've got the smarts to work out how to automatically determine the best polygon primitive type. But nonetheless, let's add a few more points there to make this a bit more visible. If I pull this one over there, it doesn't work if you start sort of having like these overlapping edges. It does work for non-convex shapes, as you can see here, but as long as the edges don't overlap, then it doesn't fall apart. And I think that's what this was doing. Yeah, so you can sort of specify the winding order. So in this case, we've got this is the polygon shape, or we've got its convex hull with its negative. That might be useful for something, I have no idea. Let me just rerun this again. I can't remember if I put in the delete function. I'm putting in a lot more points this time, so let's create a shape like this, and then go around here, and get loads more points in. There we go. Right, okay. And then go the other way around. So that was the shape that we drew, and as you can see, it's quite happily sort of come up with an optimal triangulation. The other thing that's quite nice about this is the triangles seem reasonably balanced as well. You don't end up with lots of awkward triangles to solve the problem. It's as if each triangle has strived to get the maximum area it can possibly represent. Is that a useful property? I don't know, but I thought it was an observation. I haven't proven it, but it seemed like a reasonably nice algorithm. I don't think it's ear clip. I have subsequently looked. It's not dissimilar. I think all of these things end up being quite similar, but it's not ear clipping. No. So I was going to make a video about this algorithm. So I've got 2 videos planned for the early part of the year. One is this algorithm, and the other is the Geometry 2D library, because I think that could do with a bit of a push. And get it out there, get people to really appreciate the hard work that the community's put together. So one of the reasons I've hesitated sort of getting back to you straight away, Alter, if you're still there, is in order to create polygons in a sensible way, fundamentally, is it not just better to represent them as triangles and work with them at that level? Joseph21, by the way, Joseph21 is not often on the Twitch chat. But he's a nutcase that converted all of the console game engine video code over to Pixel Game Engine for fun, complete with sort of really quite intricate, detailed analyses of the decisions that he's made as he's gone along. So thank you, Joseph, for that. And also, whilst I've got people here that might not be chatting, I've told that before, have I? Oh, okay. Well, in that case, scratch everything I've just said and ignore Joseph21. He doesn't really want any further attention. Johnny G, if you're there in the background, I have got your direct message. I have not ignored it. I just I tend to batch all of my direct messages. I do get a fair few, so I tend to batch them. Right, I think for today it's not a bad start to the year. We haven't done any code. I need to do some code now, but I'm about to lose my voice. So, thank you all very much for sticking with me and coming back this year. Thank you, Lando, for the subscription. And you can tell I'm falling apart. So I'm going to call it a day, and hopefully same time next week, and we'll get back into doing some coding. Yes, thank you very much. All right, I'm going to play the outro. Right, take care, everybody. See you later.